Well, this is a fairly interesting experiment. It's simple, but you'll understand it. We're using the slot in the chassis as the opening to dip a gear down that gets driven by the motor as the motor turns. As the drive gear for the wheels turns and gets its wheel turned. So the Ray had been doing that on all the other engines where I had a gear. And I would put this gear, either bolt it to the existing metal, like this one. I would bolt it on top, get rid of that push stick thing. Or I would, I had another one I could bolt on like this. I bolt to that. And that's how it would work. And that's how the current one was working. I also had tried to make my own gear. And this was one of those prototypes of that gear that I tested and did not use. And I'd forgotten why. And then I realized why when I found this. Oh, heck. When I found this. Now, it's a cam, as you can see, but it's a very bulbous, big, fat, round, one puff, chuff, purr, right? And I put that, I remember working with this one, and it worked pretty good. It was smooth. But I wanted 4, and I said, okay, if I can't have 4, I want 2. So I created a 2-lobe cam like this, and that's what's on the engine over there that's been working for almost 3 months with 2 puffs and chuffs. But I kind of lost track of why and how and stuff like that. Now I'm trying to create this gear with a cam on it for this ground out piece here, where we now have access to a gear that we did not have before, but we don't have the gearbox. So what I was doing was trying to cram that old gear in here, the old cam, and make that work. And it was a struggle. Everything I did was a struggle. It seems like this whole project's been a struggle. But what I wanted to show you is where we are now with this is I've got this assembly with a cam where if I touch this guy here and I push it in, you get a noise. And if I push this one here up, you get a noise. So now I'm going to simulate the gear is in the engine and working, and tell me what you hear. In either direction, you hear beep. I dropped my phone. Oh, Jesus. There you go. I dropped my phone, and it's sitting on that. Okay, stop. So you hear one beep. The beauty of that is I've got these magically just almost die across. What do you call it? Across. Okay, so it sounds like 1, but it's really 2, and that's fun. At any rate, all this mess is hardly worth it, but I wanted you to hear and see that because I thought in the end that was pretty cool. All right, so now we got our 2 puffs. Oh, there. They didn't have the light on. No wonder it was so dark. Didn't have the puffs per chuff, but now we have 2. Okay, I'll take 2 for now, and we'll work on it. I'll get a bulbous cam. Maybe this one will come back with this double hump shape. Okay. The thing was, I didn't have enough stroke at the top of the cam, and I had too much dwell between the lobes, even with this guy. I mean, it was too sharp, and the angle of attack, and then friction and physics gets involved. Okay, threaded rods and teeter-totters and all that crap. Okay, so anyway, I've got the cam lobe figured out. I had it figured out. I forgot. and now I've remembered, and I'm back on track. My mind's right, boss. And I just finished creating I had a problem with this bearing in this screw where the screw is too small. Here, I'll show you. I was faking it for a long time, but I decided I'm not going to do that anymore. If I can do this with one hand, maybe I can't. Maybe I can, maybe I can't. I think I can, Okay. Do it, just do it. There it is. Now, what you see here is there's a lot of gap at the top, and then when I let go, the bearing falls and it moves quite well, too well. So what I had cheated doing was I used aluminum tape and I wrapped the shank of the screw in aluminum tape and would just press it into the bearings. So I got to fit that way. Well, this afternoon I got this thing going on inside and I said, I'm going to print my spacer the way I need to. So I went through multiple iterations of this, the tiniest, smallest, thinnest part I've ever printed in my life on my machine, on this big hulking machine. And I did it. I printed it. Well, that looks like a mess. It's coming out all right, though. It's a new one of these because one thing I'm not going to tell you about, but I guess I will now. I'm cat's out of the bag. Now that I've got this all working nice and well, this gear doesn't touch that cam. Now, what did I do different? I don't know. One thing I did was I put the spacer on this, my first plastic spacer. Instead of winding aluminum tape around it, I had one of these, and I finally got one that would fit around the screw and into the bushing with some manipulation. Filing was involved. At any rate, it's together now. It works really smooth, and the bearing is rigid. It doesn't wobble on that shank, the boss, or what do you call that? I don't know. Thread, that shoulder, the shoulder of that screw. It doesn't wobble on that shoulder. It's very snug and feels good. And it's a ball bearing, so the inner races are fixed and the bolt rollers are working, and the thing just is very smooth. And I'm just so excited because this is both cams at the same time is a good thing. Okay, now it doesn't reach the gear. Well, now what do? Well, one thing, you can get all this stuff out of here. And, of course, that new motor now is magnetized, systematized, magnetized. Whatever. Jesus. Dennis, what are you doing to me? Okay, there. Get this off of here. It's crazy. You can't do everything at the same time with one hand. You can't do hardly anything with one hand. But in any case, this is how this is going to fit on here. And it's going to... I pick up stuff every time I move this thing around because those motor magnets are so powerful. So it picks up stuff. No, it will get bolted down, but as you can see, if I hold it in this bolted position, the gear still turns. It's like, wait a minute. If it's in gear with the motor, it shouldn't turn. It can't turn back. The gear can't turn a worm gear backwards. It just doesn't work that way. So what's going on here? And then also, I can spin the motor with my hand. I can spin the armature, and the gear doesn't move. It should be moving. It doesn't move. I even put a mark on it to watch it move, and it's not moving. So I measured the distance of the plate to the teeth, and from this plate to those teeth, and as you can see from here, this has a 10-degree pitch out, and that takes that worm gear and gives it a 10-degree pitch down, which doesn't sound like a lot, but when you get it out here 1.5 inches, it's down quite a bit. It's down 3 or 4 millimeters. So I got to lower my my gear on here, and I tried to do it with this insert. You can see it. So there's a gap at the top. I put the heater in and I pulled it down, but I didn't pull it down as much as I needed to, so it's still not. So then what I went and did was I went over to my CAD file. I love CAD, right? You can do so much with it. And I grabbed this surface, and I have what I call an extrude or a press pull. I can grab that side and push it up or down. Pretty exciting, huh? So I can make it fat or I can make it short. So you can guess what I did, right? I'm gonna cancel this and come back to it, and I'll show you what I did. I did a press pull, and right there it is. I did a -1. I pushed it down 1 millimeter, and I pushed it down here, here, and here. I'll do a cancel so I don't do it again. Now you'll see the space for that screw is right at the bottom now. So here you can see is a lot more fat. So there's a millimeter out of that. I lowered the screw down. I was filing on this. I had a little interference there. I had to move it up. I also had, I don't know, for lack of a better word, slag, but I had some material piled up around the edges here, and I didn't quite figure that out, and here as well. So I filed all that out, so I had a very flat fit, so that when I held this up to this part, I held the part here, and I held it up to the light, I could see light underneath, and I thought, well, that's not right. So that's when I found the slag was holding it up, so I've done that. So now that I've made that pitch change, we're in the midst of printing this part. Oh, I know it. I slowed this down for my other work, and I've slowed it down way too much for this work, because this work is big. So I'm going to go up. Can't I go up another 25? It's still waiting. I'll bring it up another 25%. I cut it down to 25% speed so it could make my little hole better, and the spacer for the bearing and all, and it did. First one I've ever made. Works great. Now I got to get the gear engaged. Got the motor in. The motor should be running fine. I can put the wheels on, and this train should be running. I was hoping it'd be today, but it looks like with all these snafus, things not fitting, not going well, I'm going to have to. I found a tender that's just missing a pivot pin, so I can build this tender up for this engine. And as I'm looking at this, it just feels like, to me, it feels like a Hudson. Hudson because of the, it has the buttons, what we call, I don't know what, brass buttons. They were used during the old days for sensing the train was here, and it would trigger something. And they would have two connectors, and they'd go off to a thing that was powered. And when that was they were connected, they jumped those two together, then the thing would do what is a station announcement, or a man would fly out and wave a flag, whatever. We don't use that anymore. That kind of phased out after a while. But in any case, this, I think, would be a great Hudson, which is a good engine. Margaret has a Hudson. Hers is nothing like this, I'm afraid. Hers is really superstar stuff done to it. But in any case, I think that's, and this is a good size. I can put a nice tender on there. I'll come up with a custom Hudson tender too. So I think that'll all work out. I had this other engine, but it's semi-built, and it's not really the right thing, and I don't know how to do that. But then I found another chassis, you see. But, it doesn't have the groove in it. It doesn't have the slot. So I could use this chassis somewhere, but I'm going to have to cut that in there. So I'm going to have a chance to see if I can do it again. Oh, God. I hope. I know I've learned a lesson. I don't have to go this far back, and I don't have to go this far back, so I can shorten the distance as long as the gear will fit in there, and that is part of the problem. When this gear it's still touching on the tip of that, this gear gets way over here, and I actually do have to do something there, but I think I can step it. I don't have to go down so deep. Okay, so I got an Atlantic ready to go. I think this will be a 300, which is a cast metal body, lots of detail. It's called a 4-piece boiler, and this has a lot of detail. Linkage on this train is really nice, and there is some So 300s have some very intricate linkage too. It's a lot more complicated. So that should be fun. So I'm going to have these two engines, and then I know I made a deal with a nice fellow out west. He has American Flyer O gauge, and I said, well, I don't know anything about that. And he said, oh yeah, you do. It's the same. I said, well, it can't be. Well, he sent me a couple of engines. I've already put a motor on one of his engines, and I already had a smoke working on one of his engines, but none of them have the slot. So I had to do the machine, well, to do his engines, but also to do my post-war pre-smoke contender, the reverse and boiler style chassis. So now that I've got this technique, I'm going to work on one of his engines, and I'm going to take the nastiest one he sent me, so if I screw up, it won't be too bad. So I'll be having 3 of these converted engines, and within probably a month, I would imagine, really working this thing out. So I'm going to have to order some new cutters too, because the cutters I have are marginal, and they are designed for metal, okay? The other thing I want to do is I want to get this square shape, get the dimensions of this shape, and I want to get it in aluminum. Yes, I have a plan. I have an idea and a plan, and I should be able to cut aluminum on my machine easier than this pot metal steel. So whatever this is, it's not aluminum, but it's harder, but it's still stupid stuff. It's not hard steel. Anyway, I want to get some aluminum chassis. I want to build some chassis. Yes, I want to build a 4-axle chassis. I want to build chassis that connect and they're articulating, so you could have a 4-4-4-4 or a 4-3-3-4. Some big engines. I think that will be fun. Okay. Been rattling on, no reason. But I do feel good. I do feel really good. I got the cam thing. I forgot. Now I remembered. I just wasted 3 days fighting with this thing. But the switches work. The cam works. And now I got my little shim for the shoulder. That works nice. And this part will drop everything down. I'm hoping I'll get engagement at that point. If I don't, I got other problems, but I'll figure it out. I'm not worried. I know I got the pitch right on the tooth. I tested that already. It's fine. So if I have to lower it down more, I may have to just thin this down up here. I don't know. We'll see. We'll see. I'm not worried. I will get there. Okay, that's it. Gotta run. It's, what is it? 12 minutes after 5. I don't know when this is going to be done. Let's see if I can get another 25 out of it. No, it's not going to let me. Damn it. 50 minutes. Oh, Jesus, it's going too slow. All right. Well, that means I have to come sneak down later. The beauty of it is, with this new system, I can watch the printer upstairs on my PC, because this has a web address. So I go upstairs, put in the web address, and I see this screen. That's pretty cool. So I can see how much time's left and all that. I can even see it on the camera from my PC upstairs. So we'll have dinner and eat, watch the news, and I can just check. I'll say, oh, I'm going down, check on something. And I'll come down, take the part off, shut the printer down. Oh, no, she doesn't want you printing at night. Afraid there'll be a fire or something. I understand. I wouldn't print all night. Oh, although I have. I printed the Empire State Building for 3 days. Well, that's going to be a nice looking part. Uh-oh, she's got me. Okay, gotta run. Later.